Well, in this presentation, we're going to be introducing the different types of mining and the purpose of mining and how we extract metals from some of the ores. So you may not realize this, but almost everything that you don't eat is basically has to be mined for the most part. Even the drywall that's used in your house is something that has to be mined. It's actually made out of gypsum, and that's a mineral that is mined and then compressed and then put into wallboard. So this is really an astounding fact, but the Minerals Education Coalition has basically determined that every American born will need about 3.11 million pounds of minerals, metals, and fuels in their lifetime. And that includes, everything from sandstone and gravel and cement that are used for the structures that we use, to the metals that are used in the electronics, to the fossil fuels that are used for our energy, to the minerals that we need for our diet. All of these things are things that need to be. So where do we get all this stuff from? Well, we get it from mining operations. So the process of mining is actually extremely complex. The very first thing you have to do is you have to start exploring to try and find areas of the Earth's crust where the minerals or the metals that you're looking for have been concentrated. Because without concentration, then the cost associated with extracting those minerals or metals is too high and it won't be profitable. So there's a lot of geologic reasons and places where ores can be concentrated. A lot of it has to do with volcanic areas, not necessarily volcanoes themselves, but areas where magma has brought up these metals from deep in the Earth's core up through magma that's rising. Magma rises because it's more buoyant, and it makes its way into cracks and fissures, and then cools down and solidifies, trapping those metals at higher concentrations than is generally seen in the Earth's crust. And once a mining company has found a promising ore body, they need to do an environmental assessment to get approval, and that environmental assessment will determine all of the different types of wildlife and plants that live in the area, what their requirements are, and what the mining operations are likely to do to the environment, and if and the steps that they would take to mitigate the bad environmental impacts. Now, in order to get an environmental assessment approved, they don't have to say that they're not going to do any damage to the environment. They just have to say that it's going to be well managed and that it'll be minimized to the extent possible. And then once they get government approval, then they have to go through setting up the infrastructure necessary for the mine itself, and that can take anywhere from 1 to 5 years depending upon the size of the mine. Most mines generally have an operation lifetime of decades. 10 to 50 years is common. The Bingham Canyon mine here in Utah on the other side of our valley has been in continuous operation for more than 110 years, and that's really unusual. But the size of the ore body was absolutely astounding. And today, the Bingham Canyon mine is still producing more than 20% of all the copper that's used in the United States each year. Once the ore body itself is played out, the mine will go through a process of closure and reclamation. And reclamation can take, anywhere from 1 to 5 or 10 years, depending on how complex and how large the mine site is. And then once they have reclaimed the land and removed all of the equipment and regraded the land and revegetated, then they'll be monitoring the land to make sure that everything is stable and everything is moving along forward. And they have to continue to do that indefinitely. So how do you find ore bodies? Well, you have smart geologists that understand the plate tectonics and the underlying surfaces, and they use a combination of satellites, airplanes, helicopters, and boots on the ground in order to be able to identify the regions on the Earth's surface where the different ores might be concentrated. For radioactive minerals, the easiest way to do that is to actually search promising geologic areas with a Geiger counter. A Geiger counter actually just measures radiation being given off, and the radioactive ores give off that signal that can be detected. So once you have an area that seems promising, then the next step is to drill the site in order to understand the size and the quality of the ore that is actually in the ground. And a very large mining site might spend 5 or 10 years drilling in order to map out the ore body and estimate its entire volume, estimate its concentrations, estimate its market value, and then they can determine what's the best way to mine that and whether or not it's possible to do so in a economically viable way in which they can make a profit. So here are some examples of these cores. All of these cores came from a single drill hole, and a geologist will be able to go through and read through these to figure out where exactly the ore body is. And once they've identified where the ore body is, they can do chemical analysis on the core to determine the concentration of the metals in the core itself, or the minerals. So if I'm a geologist and I'm looking for gold, I'm looking for gold at concentrations that are greater than about 1 ounce per ton of rock. At that level, gold mining is actually pretty profitable. If the gold prices go up, then you can get away with mining ore that's not quite as high quality. And if the if the gold prices go down, then the ore needs to be of higher quality in order to be able to make a profit. So these geologists are really good at making these maps of the geologic areas, and they can use these to try and zero in on which areas are more likely to have ore bodies of their need, and then they can explore those on foot and with drilling. So what about the environment? Well, that part of that environmental assessment, they have to, look at all of the wildlife that's in the area, everything from amphibians to mammals to bird life. They have to look at the water bodies that are there, evaluate the water quality, and then they also have to look at the land for stability in terms of, will their mining operations create unstable land slide situations, or might earthquakes impact their operations. And all of these things are things that they have to consider when they're making their mining plan and their environmental assessment. So before a mine can be opened, they have to have that environmental study, and in part of that is so that they can figure out how to return the land back close to its original function. And it'll always look different, but if they can rehabilitate it to a place where it can function in a similar manner than what it did before, then that's considered a successful environmental remediation and rehabilitation. So just a reminder of that timeline, that exploration, can be anywhere from 0 to 5 years. They have to have permits to do the exploration. They have to have permits for all of the different phases of the mining process, but starting with the exploration. They will then be working on their feasibility studies based upon their assessment of the ore body to determine if they can mine it profitably. Then once they have made that decision, then they have to start construction on the infrastructure, and eventually leads up to production. And all of that takes significant lead time. So there are really two basic types of mining that we're going to go into. One is underground mining and one is surface mining. So the purpose of underground mining is to basically be able to mine in an area where the ore is not widely distributed, but it's more concentrated along veins or dikes or other geologic features that can be most profitably followed underground, or a situation where the ore body is so deep that it would be unprofitable to remove the waste overburden to access the ore body. So the other is a surface mine. This happens to be a gold mine in Nevada that I visited. And here they basically remove the top 150 feet of waste rock in order to expose the ore. And here you can see the different color between the orange and the brown waste rock on top and the kind of grayish ore body that is down below. And then once they got rid of the waste rock on top, the ore body was right there, and they could blast it and basically extract it. And they just kept going deeper and deeper as the ore body went down. And they have a very sophisticated way of keeping track of how steep they're going to be. And if they need to go deeper, then they have to widen the pit in order to keep the grades at a reasonable level. So here's an example on the left of Kennecott, Utah Copper's Bingham Canyon mine. It's one aspect of it. It's one of the largest surface pits in the world. They've been continuously mining there for more than 110 years. They pull out more than 300,000 tons of ore every single day. And they do this with these extremely large trucks. These two-story high haul trucks carries hundreds of tons of ore in a single pass. And they have gigantic cranes, not cranes, but diggers that can load these trucks up. The largest of them can actually load one of these trucks in a single bucket full. So there's other types of surface mining in addition to the ore body that we were looking at. You can also be surface mining for sand and gravel. That's really common. It's one of the more common types of small-scale mines. We have several of those in our valley. And then in certain places where you have rocky outcrops that are valuable, such as granite or limestone or marble or other sorts of things, then you can actually have a surface mine where you actually quarry out the rock in blocks for use. So underground mining requires a special breed of miners that are certainly not claustrophobic, and it's actually quite dangerous. An example on the left are miners that are working after nickel. It involves a lot of heavy equipment, drilling, blasting, and transportation of minerals or metal ore bodies under long distances. So in Wyoming, the coal that they mine is actually fairly near the surface, and they actually do a lot of strip mining where they remove the waste rock on top, expose the large amounts of coal, and they can do that from the surface. In central Utah, the coal mines are located in seams that are under deep enough areas where it's unfeasible to actually remove the rock on top. And so they have to go underground for that. The same is true in most of the coal mines in West Virginia and the eastern part of the United States. So one of the things that they do is they do long wall coal mining, where they have this equipment which basically grinds up and breaks up the coal and puts it onto a conveyor belt and takes it out of the mine. They have to leave pillars in place in order to support the structure of the mountain so that it doesn't collapse on them. And one of the practices that has happened here in Utah and is quite dangerous is once you have completed all the long walls, then you can go back and start removing the pillars as you exit the area. And as you remove those pillars, the ceiling will collapse and they can get as much of the coal out of the seam as possible that way. So extraction really is the process of removing these mineral resources from the Earth's crust. That's what the mining engineers are responsible for, figuring out how to do it efficiently and safely. And so what they do is, for the surface mines anyway, they drill large holes, and then they fill these holes up with explosives, and then they explode them, which breaks the rock up into large chunks. So here's an example of one of these carefully controlled blasts. And as soon as the blasting is done, the large diggers will move in there along with the large trucks. to actually load that up and take it to the crusher. So here we go with the loading of these trucks. These trucks are so large that they can't really see regular vehicles that are driving. So the regular vehicles that drive in the mine have to have these really tall flags so that the drivers of the big trucks can actually see them. And they haul the ore to the crusher, which basically breaks up the large clods into smaller pieces so that everything that goes through the crusher comes out kind of like the size of a grapefruit or smaller. And then, we have to, once we have this crushed ore, we still have to figure out how to get the minerals or the metals out of that. And that is the domain of the metallurgical engineers. And they've come up with lots of clever ways to get the metal and the minerals out of the ore bodies. So one way is to physically mill the rock, which is to basically grind it up into a powder. But that is very energy intensive and very expensive. It can be worthwhile, for example, if you're going after a valuable mineral or valuable metal, in this case like gold. This particular quartz site has specks of gold in it, and if you grind this up, then you can actually find a way to extract the gold from it. Another way to do that is once you've kind of processed the ore from crushing a little bit, you can put it into water and you can insert chemicals to further break it apart. You can pump air in and agitate it, and you can put in special chemicals that will cause the metals that you're looking for to basically rise to the surface on these bubbles, and then you can skim these bubbles and foam off of the top of the water, and that will be a heavily concentrated metal in that slurry. And one thing that you can do once you have that concentrate is you can smelt it at high temperatures, and this will basically remove base metals and impurities from the concentrates. And the smelting requires extremely high temperatures in excess of 1,000 degrees Celsius. And if there's any kind of sulfur that is in the ore body, then that sulfur will be oxidized to sulfur dioxide gas, which is a criteria air pollutant, and would need to be scrubbed from the smokestack before it is emitted into the atmosphere, which is quite a expensive process, but necessary to meet the environmental regulations. Another method for removing metals is called leaching. We talked about this a little bit before, but they take the ground ore and pile it onto pits that are lined with tarps, and then they will pour a solution on top of it containing a solution that has an affinity for the metal that they're after. So for gold, cyanide is typically the solution of choice. Because cyanide has a very big affinity for gold, and as it leaches through the pad, it will remove the gold from the ore, and then it'll be pumped out the bottom, the impregnated cyanide solution that has lots of metals in it. They'll strip those metals out of the cyanide, recycle the cyanide, and send it back to the heap leach pile. And they'll do this for about a month in order to remove the metal from the ore body. So electrowinning is another type of process by which the metal can be pulled from an impregnated solution. In this case, it uses an electrical charge passed through, over at the Kindergarten copper mine, it's through copper ions, a copper impregnated solution, and the copper ions will stick to one of the sheets and will generate these large sheets of almost pure copper, 95 to 97% copper. So how much land do we use for mining in the United States? Well, if you look at the land used by agriculture, that is by far the largest land use in the United States. The land used by mining is significantly smaller and has been decreasing significantly as 50% of that land has already been reclaimed in the last 80 years. So once a mine has played out, they then must go through the process of reclamation and try and return the land to useful purposes, not necessarily the same as before, but useful purposes nonetheless. So here's an example of a mining area that was reclaimed in West Virginia. Before the reclamation, you can see that you have waste piles, you've got ponds, and that sort of thing. And then afterwards, it's been reclaimed. In this case, it was turned into an amphitheater. That's not the commonly what's done, but that's what was done in this particular case. This is much more common. So here's an example in West Virginia where you've had a mined out area with tailings and other sorts of things, and they have essentially revegetated, covered up the toxic tailings pile with overburden, and in this case built a road through the area so that people could use it for recreation. So here's an example of the McLaughlin gold mine in California. It had a fairly large footprint for the operations once the mine was done. They removed all of the equipment, they regraded the slopes, they revegetated, and now you can see that you have an area here that's different than it was prior to the mining, but yet it is still an area that is useful. And then we have resources, additional resources that you can look at to learn more about mining if you have an interest.